Quiet, please. Let's get started. Yesterday we covered four, right? Four bigly ones. Four.
Okay.
We got to finish the last two.
Of 8.
What were the two we didn't do? Secant and cotangent.
Yeah.
So the question is, first, what's the derivative of the secant function? Okay, well, the first thing we'll do is say, well, secant's kind of a weird-looking dude, right?
Yes.
Let's rewrite him. Yeah, it's 1 over cosine. So I would rephrase this as, what's the derivative of 1 over cosine? Well, beans. Now what rule can we use? Quotient rule. So the quotient rule, f over g turns into f prime g minus g prime f all over g squared. Okay, so that's my f, that's my g. So what's f prime?
0.
And if you like to write it out, you can do that too. You can say, oh, f is 1, so f prime is 0. G is cosine. So g prime is negative sine. So f prime times g minus g prime times f. And it's all over
Cosine squared.
g squared. Cool beans? Holidays aren't real. It's all in your head, bro. Just mind over matter. You just gotta have a can-do attitude. Nose to the grindstone. Elbow grease.
Where that saying came from, like, nose to the grindstone, like, wouldn't that hurt?
Most
Not if
days.
you pull yourself up by your bootstraps. Pain is just pain weakening. Pain is just weakness in
That's
the
like on the
body.
same
Leaving the
level.
Is weakness.
Oh, there you go. Allergies are just a failure to
Of genetics.
To have superior
something
genetics.
leaving the body.
Thank you.
Okay,
It's failure to be an area.
0. So this is going to be minus a negative. So positive sine of x. And on bottom we have cosine of x squared. So I'm going to do the same trick we did last time with the cosecant. And think of the top as sine times 1. And now I can see I got a product of two thingies.
Of 2 things.
So, and I'm gonna reverse the order if that's okay. What's 1 over cosine?
Secant x.
And what's sine divided by cosine? The tangent of x. So look at that result. It should make it, yeah.
I had it as sine of x over cosine x squared. Is that technically wrong?
Yeah.
You have it as sine of x. No, sine of x over cosine squared is not wrong, but this is they typically like to write it like this. And I think the reason is, look at the final result. The derivative, it's really interesting result, I think. Taking the derivative of this function is the same as multiplying the function by tangent. That's kind of weird, right? So, but yeah, it's certainly not wrong to say the derivative is sine over cosine squared. Certainly. So compare these two. Do you see the pattern? Well, I mean, maybe it's not. Maybe I'll call it a pattern, but a similarity. So secant turns into secant tangent. Cosecant turns into negative cosecant cotangent. So it's kind of a parity there, right?
Mm-hmm.
Okay.
Thank you, Winky.
Thinky. Are there any questions? No? Okay, this is a known result now. This is something that this is a big one. Okay? Yes?
Why do you make I want over cosine of x again?
Well, so getting from here to here. Well, so I just simplified the top is just positive sine of x. And the bottom is cosine squared. And because I was planning, like I could have just written this as sine over cosine squared, but I wanted to break it up into two things. So I wrote cosine squared as cosine times cosine, and I wrote sine as sine times 1. That allows us to split the fraction up into two. All right, let's do cotangent next. Yeah? And this would be among the small set of things you have to memorize, like because especially if you're taking the AP exam, like you would need to have that memorized. Otherwise, you're gonna have a hard time. And so thinking ahead, here's the thing. Why might you want to make sure you know this result? Well, think ahead to when we start doing integrals. What's the integral of secant times tangent? Secant. So you're going to have a really hard time if you have an integral of secant times tangent and you don't know if you don't know to look for this, then you're going to, let's see, could you do that one by hand? Maybe it's possible. It would be a pain though. Way easier if you just know that famous result. I have a nice printout that I made for you that is going to summarize all the things that a person should have memorized for a Calculus 1 class. I'll give it to you shortly.
Much appreciated.
Now we're going to finish this front side today. So it's just exponential, log, sine, cosine, tangent, secant, cosecant, cotangent. All right, cotangent time. Derivative of the cotangent function. Taking bets, taking guesses.
1/10.
What's up? You got a question?
No.
Okay.
I think I had the answer.
Oh, yeah.
I'm gonna wait till you ask your question though.
No, the question was just based on what the derivative of tangent was. Do we think we might know what the derivative of cotangent is?
Or I'll just say what I got negative secant squared over tan squared.
I think that's correct, but
Yeah.
it could be simplified
Okay.
a lot.
Better.
So let's do this one the same way we did the tangent. So cotangent is the reciprocal of tangent, right? So instead of sine over cosine, it's cosine over sine. Okay, does that make sense? Yes. Hopefully. Okay, so quotient rule. So if we're going to do the quotient rule, this, I'm going to call that my F. Top is my F. And the bottom is my G. So what's F prime? Negative sine. And my G prime is cosine. So now we're going to do the whole, we're going to get our F prime G minus G prime F all over G squared. Aaron, what would you say your answer was? Say it one more time.
It was definitely wrong.
No.
Oh, but I had the negative secant squared over tangent squared.
That's correct. That's correct. Pretty sure.
Well then, okay.
We're gonna come back. We're gonna come.
Well, I'm confused then because I set it equal to 1 over tangent x.
That's the same as 1 over tangent of x, right? I'm gonna come back to your answer though, because I like your answer. So anyway, because certainly if you know the derivative of tangent, so you can do the derivative of 1 over tangent, just involving that thing. I think this is a bit easier, personally, Because I go f prime, so f prime g would be negative sine times sine minus g prime. So there's our f prime g minus g prime f all over g squared. Are there any questions on that? No? Okay. Now, the top, these guys both have a negative 1 in front of them. So I think we should factor out the negative 1. And what's left over?
Sine squared. and
Sine
cosine
squared. Everyone understand that?
Mhm.
Okay, cool beanies? Yeah. One. So the top is just negative 1, the bottom sine squared, so negative cosecant squared is the answer. Now, here's what Aaron told us. Now, if I take this and I go, well, this secant squared is negative 1 over cosine squared, and tangent squared is sine squared over cosine squared. Fraction divided by a fraction. Right, reciprocal to denominator, right? Just making sense? So you can see, you were correcto. Isn't that lovely?
Mhm. Good job.
See if I know how to get that.
Now, how did
Oh,
I?
wait,
Save some brain power for the rest of us.
Already boxed up.
So this is the answer that Aaron said, and I was just saying that Aaron was correct. He just had a little bit of simplification to do.
Are they the same thing?
Yes.
Well,
I'm going with the way you did it, because
so Aaron took the result from yesterday, that the derivative of tangent is secant squared, right? He wrote cotangent as 1 over tangent and proceeded that way, and he ended up with this. And then you'd have to take a couple more steps. Now, I think that writing cotangent as cosine over sine simplifies the derivation a little bit, but that's the whole. I mean, what makes math interesting and the reason you do it is you can see that those are both equivalent. Those are both they're consistent, right? They fit together. So, now, use them. Here, I'll give you these sheets here. Todd, I like this. Pass them around here. Here, Mr. Trenton, take one and you did your job for me. Wow, wow. Think of the time I saved you. You could have side hustled while I did that for you. You could have monetized the things that you enjoy doing with your life. You know? Monetize them. That's all you gotta do. That's all you gotta do. So, while I'm erasing here, think about this. How does the chain rule apply to all of these things we just did? Is the chain rule going to be different for trig functions? No,
No.
definitely not.
Let me guess.
So the derivative of sine of x is cosine of x. What's the derivative of sine of u?
Cosine
Prime
times.
Same
Oh,
prime
goodness.
sine of you.
Close.
I feel like maybe the twins will be going up.
I'm not going to write every single one on the board because I gave you that sheet, but like,
I gave you that sheet.
I mean, so This is just yet another example of how the chain rule works. The derivative of sine of x is the cosine of x. Okay? So therefore, the derivative of the sine of u is the cosine of u with u prime attached. It's as simple as that. What's up? Nuh-uh.
Well, I took one for Jesse, but
Big brain, she doesn't need them.
I'll print them. I'll print them in a few minutes,
that's
okay?
what it does. She's human like the rest of us.
Okay, cool beans. So that holds for all of the ones we just did on this page. So, what's the derivative of tangent of u? U prime times secant squared of u. That's all you gotta do. Cool beans. So let's do a couple derivatives, and then we're gonna have some work time. You guys, you can have 20 minutes to just work on your assignment. What's the derivative of sine of 3x?
Cosine of 3x.
3, so that's u prime times cosine of u. How about cosine of x squared plus 1? There's the u, u prime. Right, and then there's going to be a negative in there. So if you're getting comfortable with looking ahead, this is kind of a clunky way to write it. So you could write it as negative 2x sine of x squared plus 1. Yeah. Okay. Now then, not all of them are just a plain simple chain rule. Some of them might be like D. What do you need to use for D? Quotient rule. How about E? E's a little bit weird.
Would it be the product?
Oh, you could do it that way. I didn't think of that. You could also do it as for E, it's sine of x squared. So you could think of that as being a u squared turning into 2u prime. That's the other way you could do it. But yeah, the product rule would work too. You could write it as sine times sine and do the product rule. So. All right. How about F? What do you got to use for F? That one's definitely product rule. Yep. G is going to be like a chain rule inside a chain rule, right? Because you have to, for G, you kind of have to treat that as a u to the fourth. But then the derivative of sine of x squared is another chain rule in and of itself. So, all right. Okay. Are you guys sufficiently miserable?
Yes.
Good. Job well done.
Indeed.